I believe in make-believe, fairy tales and lucky charms, and I believe in promises.
Hello everyone, Amitabh here. Today you're going to learn about some general toolchain knowledge and basics such as linking, compiling, assembling, etc. Memory related locations like segments, header sizes. Also for binary you're going to learn about overwriting the ROM with ARMIPS and some general ARMIPS basics which you can also learn from its docs in its GitHub source code repo. Check the description for the link for that. The basics will be shown at the end of the video when we do a practical demonstration. You will also learn for binary how you can use compile languages such as C, C++, Rust, etc. Preferably C in this series. In a future video, I will show you how to work with my SM64 injection template in my GitHub that can be used for this. Check the description for this source code. Toolchain knowledge and ARMIPS basics. Let's talk about toolchain in the order things are compiled. Now a compiler compiles the code directly into machine language. Some information of data like addresses or incomplete addresses that the compiler doesn't know of, which will be solved by the linker later in the compilation process, is contained in it. This file is called the object file. Assembly files can be assembled into object files as well. But in binary, with ARMIPS, we don't really need assembly files assembled into object files, as ARMIPS is a linker and assembler. The linker links a single or multiple object files into a single library, such as the C library, to make it an executable normally. This is normally an example for Linux or Windows or shit like that. But in ARMIPS, we can import how many ever object files we want at any location. By the way, the last topic of the video will be a practical demonstration of ARMIPS. Talking about location, let's talk about memory basics. In vanilla Super Mario 64, there are three major segments: Goddard, main, engine. Segments. Memory can be used properly, saving space according to what is necessarily needed to be loaded using segments. Majorly for level segments, this saves space in the RAM, which we will talk about more in the future videos. Now let's talk about header sizes. These are used in ARMIPS, so we can overwrite on the basis of RAM address. So we do not need to worry about finding the ROM address of a specific thing. For example, the main segment is located at 0x1000 in the ROM and at 0x80246,000 in RAM. The header size is 0x80246,000 minus 0x1000, which is 0x80245,000. To find the ROM address of something located in the main segment, subtract that RAM address from the header size. Header sizes correspond to the header or the first offset of the ROM, which is 0, like the full first ROM address. When we add 0x1000 to it, we reach 0x80246,000, which is why header sizes work. Now let's learn about how we can use compile languages with ARMIPS for binary. Object files which are compiled from a code can be imported or injected into a specific address. This is possible for C, C++, Rust, etc., as they are compiled languages. Preferably, we will use C in this series, as it is compatible with decomp as well. More on this when we start using SM64 injection template, which again will be in the description. And as I said, here's a practical demonstration of ARMIPS. Okay, so here's a demonstration. So I'm just gonna create a folder for this. Okay, I'm gonna copy ARMIPS to here. I think it's here. Okay. So ARMIPS works, I guess. Yeah, it does. So I'm just gonna. So I'm gonna call the ASM file test.asm. Oh, yeah, actually, I should have a row. I'm gonna use the USA ROM here. So as a demonstration, I'm gonna enable what is that? Yeah, I'm gonna enable debug level select. Now I don't remember like every single address in the whole game, and I don't even remember for the debug level select. So I'm gonna show you people how to get it. Okay. So I'm gonna make an assembly file. I'm gonna call it test.asm. So what is gonna be in this file? We want to open a file called Super Mario 64. Wait, what is the name again? Yeah, this. We wanna open this file. And the output file will be romout.z64, and as of now we are gonna have the header size to be 0. You can do 0x0 or 0. I just like to do this so people know what this is. You can use a double slash asterisk and semicolons or as comments. So I'm gonna use this. This opens a file called first argument, which is this. This is the second argument. Now you may wonder why I'm setting it to 0, because the debug level select variable is located in the main segment. Well, you can set it afterwards to like this header size, but I'm gonna show you how to do that. So header size, the header size is dot header size 0x8024 6000 minus 0x1000, and there are two types you can do here. You can do .org and you can do .orga. We are gonna use .org, but .org is for let's say you enter like a random RAM address here. So .orgs are used for RAM addresses, and .orgas are used for ROM addresses. For example, this. It's just an example, not accurate. Now let's find the address of G debug level select. I'm gonna go to my decomp repo, build US folder, and go to the map file. Let's search for G debug level select. I'm gonna copy this entire thing because I want to show you people something. If you make, oh wait, yeah, I forgot one more thing. After the open, you have to put .n64, so ARMIPS knows we are coding for N64, since ARMIPS can be used for other platforms as well. Anyways, talking about this, what we are gonna do is we're gonna use this. We're gonna do a .define label, a G debug level select 0x803.2D58C. We can do the same for the header size actually. .define label main section header size to be 0x80246.000 minus 0x1000. If you see my SM64 injection template, I did kind of like the same thing here. Wait, no, not this one. Sections. As you can see, I set the ROM and RAM, and then I subtracted them to get the header size for main, engine, and Goddard. Now let's do this. So to set G debug level select, so everyone level select, this variable has to be the value of 1 or 0x01. So what I'm gonna do, I'm going to .org G debug level select. Also, fact, you cannot do .org because this is a RAM address and not a ROM address. If you do want to do a ROM address, you can do .org G debug level select minus main header size, and then do it too. It's no problem. But this is for your understanding, and it's more easier to understand. If you want to make a new line, you can use double colons, and then we are going to use a directive called .byte, since we are setting only a single byte at this location to 0x01. That's pretty much it. You can even make it a one-liner. Can make everything one-liner. And we are basically done. The last thing is we just got to close this, because we opened it. Now we gotta close it. Now if we run ARMIPS on this, okay, let's see, let's run ARMIPS test.asm, and we are it's done. Let's try it out. So this is the normal SM64 vanilla ROM.
Hello. Hello.
As you can see, it normally leads. As you can see, normally if I press start, it's gonna lead to the file select. Now let's try this on the ROM that we made. Oh yes, I forgot one more thing. You have to also update the checksum of this ROM. It is the reason why it doesn't load right now. There is a tool for that called N64 CRC. So I'm just gonna copy that right now. Now let's run this again.
Hello.
As you can see, it runs now.
Hello.
Now let's press pause. As you can see, we get immediately to the debug level select. So it does in fact work. Yep. Thanks for watching this video. See you in the next tutorial.